ready. Friendship 7 is ready for adventure in outer space.
In the 2024 film Fly Me to the Moon, Scarlett Johansson plays a marketing expert trying to sell NASA's moon missions to the world. And while Hollywood took some creative liberties, some of the ads were real.
Omega.
Look, this isn't Madison Avenue. We don't pay for this stuff.
No, it's cost-free. The brands get a tie-in money can't buy, and NASA works its way into the minds of everyday people.
Swiss luxury watchmaker Omega did send their Speedmaster Professional to the moon in 1969. In fact, the device was the only watch to pass the reliability tests needed in order to function in space. More than half a century later, Omega is partnering with Swiss startup ClearSpace to support a world-first initiative, cleaning up debris from space.
Space environment is rapidly changing. For 60 years we've been putting satellites into orbit, and we essentially don't remove them. ClearSpace is a startup that we built to address the growing problem of space debris. What we do on the first mission is that we have to pick up an object that orbits at 28,000 km per hour. So you have to rendezvous with the object without gravity, in floats without friction. So any contact you have with the object will produce movements and rotations. We have this large closed system that just envelopes the object when we get close and then closes down, then secures it. We're going to slow the object down and make sure it falls into Earth's atmosphere where it burns up, just on the right spot, over the South Pacific, over Point Nemo. What's happening right now is that the traffic is exploding because the cost to put 1 kilogram into orbit reduced substantially by a factor 10 to 20. We send much more satellites into orbit today than we did in the past. All the predictions we made in the past in terms of risks of collision in orbit are not really applicable anymore, right? So the risk is growing very rapidly.
Why only talk about sustainability on Earth? Why not talk about sustainability in the sky? These thousands and thousands of debris that are just around us, that are basically also a danger for everything that is on this Earth.
When we started, the question was, with whom can we collaborate to build something that ambitious? Omega was kind of a natural fit out of the gate, so we reached out to them.
I would never forget the first meeting. We met with Luc, and he explained us with a small Lego.
We had long discussions about marketing impact and marketing value of our project. Renens had out of the gate this very positive approach, saying this is a fantastic project.
One of these big pillars of our DNA is of course, the Space Odyssey. Looking at this, Omega always been very much involved in what's happening in the sky. You know, in 1962, we had the first ever Omega in space by Wally Schirra, his own Speedmaster.
I was talking about Wally Schirra. You see, that's exactly the same. First Omega in space. He took it as his own watch.
As Wally Schirra masters manual spacecraft control.
That was 1965. First spacewalk, and of course 1969.
The best example of this is obviously Apollo 13, where we had to bring down the astronaut to Earth after this big engine electricity problem, and the famous moment where they came back in the atmosphere, where they had to count 14 seconds. Because it was so important in terms of timing, measuring time, measuring seconds.
Apollo 13 should be out of blackout at this time. We're standing by for any reports. Another chair in the control room as we had splashdown.
What drove me to get started on this is the realization that the most valuable asset or currency we have is time. And I wanted to have more of an impact with my life. The opportunity to pioneer something, to bring positive change in our environment, and to leave the world a better place for our kids and their kids.
We very easily understood that it was a win-win strategy. Also, let's face the reality, for us as a marketing pillar, because yes, we believe in what they do, and yet we think that that's also something that will be very important already today and in further generations, because everybody in the world is looking at it as an investment that is necessary.
The space economy is expected to triple in the next 10 years, boosted by growing needs for connectivity, as well as the democratization of smaller and low-cost satellites. As a result, space sustainability has become a pressing issue, and one worth investing in too. ClearSpace's unique offering led to a partnership with the European Space Agency and a contract of 86 million euros.
The first mission with ESA is about 120 million euro. Most of it is the non-recurring engineering cost.
Whenever you meet engineers, incredible scientists, super smart people like him, you need to find a way, as a CEO with my team, of understanding each other about how our values will fit. Much more than just how much money we will invest and how much we will get. It's also a very technical and scientific project there. We cannot check ourselves if this has a validity or not. So it means also trust, but it means more than anything, a common vision, a common values.
If you look at the last 60 years of space exploration, the first missions, if you take the mission to the moon, didn't make any financial sense, if you think of it. But it stimulated the US industry at a level that today they're still benefiting from the effects. It's always a balance between how willing are you to take risks, right? So you might say, okay, I'll invest less, I take the risk, but then I have to repeat if it fails. Or I invest more and then I take less risk and I'm more sure it's going to work. And if you look at the space industry in general, this is a recurrent. You see, for example, Ariane 6, it's a lot of investment, but the first flight worked. Compared to SpaceX, SpaceX has no problem to burn through spacecrafts and make them explode as long as they learn, and it's one strategy.
ClearSpace's first mission was originally set up to target and bring back a 112-kilogram Vega rocket payload adapter. But in April 2024, the goal changed.
This object entered in collision with the space debris on the 1st of August of 23 and generated 15 other debris around it. So with ESA, we decided to change target. It was safer for this first mission and move from the West Barbara Park to another satellite ESA owns, which is called Proba-1.
Despite being only the size of a television set and weighing just 100 kilograms, the Proba satellite is the first fully autonomous ESA spacecraft.
We don't yet have the exact launch date. It's probably going to be more around the 2028 range.
We know it's going to be a journey that will have up and downs, but we know that every day that is passing is a day towards the results.
It was phenomenal to have a partner that has our back in difficult times. Their sense of quality and precision is something that inspires us. It's almost orbital timepieces, right? So it's very close to it in the sense that a space mission is a very precisely timed exercise.
We learned a lot from him, but we could understand that it was not just another scientist project. And that's what we liked. The charisma of Luc, his own story, and this dedication of reaching a new, I would say, extraordinary moment in space.
We went inside ClearSpace's clean room, an environment that reproduces the conditions in space. For this, it needs to be completely dust-free to avoid any dust getting stuck in the mechanisms.
The reason why we built this is because this allows us to test it on air-bearing table. Then we can do the test of the capture in 2 dimensions, see how it rebounds, what the forces are, how the movements happen, and then calibrate our simulation system using this hardware. Oftentimes when you do a space mission, you cannot eliminate gravity on the ground, so you have to find tricks on how you're going to test to make sure it's going to work in orbit before you get there. We have a darkroom as well, where the objective of the darkroom is to reproduce the space environment, where we use robotic arm to simulate the physical behaviors of objects in space, and then we reproduce the space environment images or the sensors output that we need to train our system to have the right behavior when it will have to operate in space. We can also simulate or validate the complete operation initially through simulations, but then also through this flight hardware to make sure that the complete operation is actually going to work in space. So this makes our operation much more predictable, even though everything on the spacecraft is essentially autonomous.
With over 1 million debris floating in space, the task to clean the low Earth orbit seems gigantic, if not impossible.
We have to start with small steps, right? So the first mission with the European Space Agency removes one object. We already work on the second generation with the UK Space Agency, where the objective is to remove 2 objects and to be ready to refuel our servicer in orbit. Imagine the motorway would have grown for 60 years, cars go faster and faster, there's more and more cars, more and more roads, right? And there's no tow truck and you've got broken cars everywhere. It's dangerous to drive on the motorway because of all the debris. And then you say, I'm inventing a tow truck.
Most man-made objects in space can be found in the low Earth orbit because it is the easiest to reach in terms of energy and rocket power. Not only does this create light pollution, obstructing our view of the sky and disturbing natural ecosystems, the rising number of satellite debris in this orbit also impacts the atmosphere, due to the chemicals released as they disintegrate. This space also recorded a 17% increase in close approaches, where 2 satellites nearly collide. Collisions lead to additional debris and can cause a cascade of further collisions.
Most of our economy depends on space infrastructure. You can order something in China and get it shipped to your home because of space infrastructure. We use it to synchronize our servers, to synchronize our banking system. So we have so many things that are completely dependent on those space infrastructure that we cannot live without them anymore. So what we need to do is create an environment that is just self-sustaining.
As a very big company in the watchmaking industry, sustainability is so important. You know, a watch is eternity. A mechanical watch is functioning not only for 1, for 2, for tens of generations.
All those are building blocks that once you have them and demonstrate their feasibility, their functionality and their performance, you can reassemble for many different types of missions. And in that sense, it is a completely scalable system. It's like, is Lego scalable? Now, for us, the ideal case is to have a reusable platform in orbit. The next question is, how do you make a satellite that is demisable as clean as possible?
These visionary people, like Luc, are extraordinary personalities, and they give their time, their brain, their money for a target that is today and will be one day so important, and we will be thankful for that.
Sponsored by